Okay, this is now solving for x when you are trying to get rid of the powers. Now last video I tried to do it with the roots, now I'm doing with the powers. Anyway, so once again, our method, get x on its own. We can clearly see that this minus 3 is being an idiot. Let's get rid of it. Let's just take this minus 3 over, and then it will become plus 3. And we write this as 5 plus 3, which is equal to 8. And obviously we have 2x squared on its own. Now we need to deal with, remember we can't deal with the x squared yet. Why? Because we still have this sneaky little 2. Remember, this is also written as 2 times x squared is equal to 8. So over here, we have times 2. Remember what I told you? Commutative laws, it doesn't matter which order, therefore it's still times 2. We can take this times 2 over, and we'll write it as divided by 2. Remember? Because you are flipping the signs. Now we have x squared on its own because we took the 2 over, but now we write this as 8 divided by 2. 8 divided by 2 is equal to 4x squared over here on this side. Now, you need to pay attention here. Let's look at this, right? Remember when I taught you in the previous lesson, I showed you that if you have, let's say for example, the cube root of anything inside, you basically just put brackets and you raise that to the power of whatever the number is on the root. Let's say if it was the square root, like here, which is basically written like this, you just raise it to whatever numbers here in the root. So you just do that so that they can cancel. If you put this 3 over here, they'll also cancel. So in this instance, we are doing the opposite now. So instead of raising it to the power of whatever number is here, we are going to root it to the number of whatever is in the power. We're basically doing the opposite of what we did. Remember, that's what this is about. Whenever we are solving for x, we're just doing exactly the opposite of whatever is existing at this point. So in this case, if we're trying to get rid of a power, we have to root both sides from whatever number is being whatever the exponent is. And we clearly see that this is to the power of 2, which is the same over here. This is the square root, which this means now you can also cancel these out. And obviously what you do on the one side, you have to do on the other side. So you also have to square root the other side. Now, listen to this, okay? We need to pay attention. I wrote this down. Odd exponent equals no plus minus. But even exponent is equal to yes plus minus. Now, what does this mean? This just means whether you must write plus, minus, or not. Now, let's look at this, right? It's actually even or odd root, but let's look at the exponent for now, because right now, we can clearly see with this root, okay, let's write it now like this, right? X is on its own because we cancel these 2's out. X is equal to, and now we have plus, minus. Why do we have plus, minus? Because this is actually the second root. This is an even number. And what did I say? If it's an odd number, you do not put a plus minus. If it's an even exponent, you do put a plus minus. And I'll explain why we put plus minus. It's plus minus the square root of 4. This is just equal to plus minus. You still keep the plus minus. What is the square root of 4? The square root of 4 is just equal to 2, if you put it in your calculator. Now, what does this mean? Let me show you. It's going to be a little bit of a longer video, but let me show you. If we were to substitute, this is basically what it looks like, right? X is equal to positive 2, or x is equal to negative 2. That's what the plus minus sign means. It's like plus or minus. So it's the positive version of 2, or the negative version of 2. This is done because both values should be able to give you the same answer as the other side. So, right now we can see on the right hand side it is 5. So let's say if we substitute in either one of these positive or negative 2, we should get an answer of 5 on the left hand side. So let's look at the left hand side, right? We are checking. So the left hand side, we are going to say 2. Let's use the x is equal to positive 2 first. We obviously write our bracket, 2 squared. We're just basically replacing the x with whatever we have solved for, is minusing 3. And that's just going to be equal to 2 squared, which is equal to 4. 2 times 4. Remember, we always do the square first. Minus 3. It's going to be equal to, and then we have 2 times 4, which is equal to 8 minus 3. 8 minus 3 is just equal to 5. Now let's look. As you can see, 5 is on this side, but as you can see, it's also on this side. So it's equal to 5. 5 is equal to 5. It is correct. Now, let's do the right-hand side. The right-hand side, let's substitute negative 2. Remember, we also got a negative 2. Let's see if that also works. Now, so we have 2. We're going to use the same thing. We're going to use this side. We must make sure that it's equal to 5. 2, substitute the 2 in, negative 2, sorry, minus 3 is equal to, we have negative 2 squared, and we know that this this exponent is going to affect the entire bracket. Now, what does that mean? Let me write it down here quickly. If we are saying negative 2 squared, we are just writing negative 2 times negative 2. Am I right? And we know that this can also be written as negative 2 times negative 2. And let's look at this. First, let's look at the signs. A negative times a negative, we already know is going to give us a positive. And 2 times 2 is positive 4. And that is why whenever we have a square, and it can only be an even number, if you're raising the power of an even number, you'll always get a positive outcome. So we now know that the square, negative 2 squared is equal to positive 4. So let's write that down. 2 multiplied by 4 minus 3. Now you can see this line is the exact same as this line, so we already know that it's going to be 5. Therefore, both of them are correct, as you can see. So that is why we write plus minus 2 as whenever we have an even exponent, or I'm just going to say a root. If we have an even root, like if we have 2, 4, 6, 8, any even number over here, we will always say plus minus. Now, let's do the other example. Pause the video. If you need to backtrack, go for it. But this is just to show you on what is happening with an even. It's more work when it comes to even exponents. Now let's do the odd exponent. Let's do this. We have 3x to the power of 3, or 3x cubed, plus 4 is equal to 31. Now, once again, we need to get x on its own. But what we can do is we can take this plus 4 over, and it will become a minus 4. This minus 4 is going to be on this side now, and this plus 4 is going to be gone. This can be written as 31 minus 4. 3x to the power of 3. Okay, and 31 minus 4 is equal to 27. 3x cubed. Now, remember we need to get x on its own, and the best thing that we can do is, remember, 3x cubed is also the same as saying 3 times x cubed. So, clearly we can get rid of the 3 right now. So, we can take the 3 over, and remember what I said, because it's multiplied by 3, if you take it over, it's going to be divided by 3. 27 divided by 3, and we have x cubed on this side, is going to be equal to 9. X cubed here. So, let's look at this right now. X cubed is equal to 9. And remember what I said? Whenever we have a exponent, if you are raising something to the power of whatever number, we are going to root it to the power of that we're going to root it with that exponent. And in this case, we are going to take the third root, or the cube root of x cubed, so that these can cancel out. Remember, once again, these numbers have to be the same in order to cancel them out. That is one thing. And remember, what you do on the one side, you do on the other side. We also have to take the cube root. Funny enough, I actually thought it was going to be the square root, but I don't know why I did this. But anyway, let's just write this. X is now on its own because they cancelled out. And now we have the cube root of 9. this is going to be a decimal number. I'm not going to use the calculator. I don't have one at the moment on me. I'll just leave it as the cube root. But now, this is the part where we want to see if we write plus minus or not. Now, let's look at that. Remember when I said odd exponent or odd root in this case means no plus minus, and because I don't have my damn calculator right now, you guys can check it out. What I want you to do as homework, I want you to write down, if you give, let's say you have write this down on your calculator. What is the cube root of 9? And if you write down the cube root of 9, whatever number that is, write down the negative version of that and also the positive, and substitute both of them into this equation to see if you get 31 as an answer. And if you don't get 31 as an answer for both of the plus and minus, positive and negative signs, therefore, that is proven exactly why you cannot use a plus and minus. And I think I'll go into more detail in a new video, but for now, just know that when you have an odd root, in this case, never use a plus minus. If you have an even root, you always use a plus minus. And obviously you can backtrack if you're still lost on that part. But that is how you do if you want to get rid of exponents when you're solving for x. Thank you so much for watching.